Hi folks, welcome back. In the earlier video, we talked about what is Anthos and then basically how this an entire Anthos stack is dependent on a component called a fleet, and then the different scenarios. Like in the first scenario, we have observed that we can create GKE cluster in GCP environment itself, and then creating a GKE cluster in Azure environment, and then in AWS environment, as well as any other on-prem environment. That's the first scenario. And then the second scenario, even the existing Kubernetes clusters in the respective public clouds are an on-prem environment, like the AKS cluster which is running on Azure, and GK cluster running on the EKS cluster running on Amazon. Even that can be attached and made as a part of the existing fleet, and then even those clusters can also be managed in a single control plane. So now let's discuss more about the scenario first, where creating a GK cluster on GCP itself, and then in the Azure environment, and then in finally creating the GK cluster on AWS environment. So since the creating a GK cluster in Google, it's a straightforward method that directly we can see during the implementation video itself. So I'm skipping that portion for now, and let's focus on creating the GK cluster on Azure and the GK cluster on Amazon. So let's see the architecture of GKE on Azure. So if you see in this architecture diagram, the key component, the key components I can say are the Anthos Cloud API and Connect API. So what are these two? So it's like either you can create these GK cluster directly from the GKE console. I mean, you can go to browser and you can hit the Google Cloud Console, and from there directly you can try creating the GKE cluster through HTTP, the requests and all. Or you can use a command line method or any other, automation methods. The popular one is like, the Terraform. So in this diagram, if you see, let's assume you are creating either with the help of gcloud command line utility or Terraform automation scripts. So when you create it, it will utilize something called as Anthos multi-cloud APIs. So if you come down in this architecture diagram here, they have given examples for both command line utility as well as the Anthos multi-cloud API. So if you see here, gcloud container Azure. So if you come down and click on the clusters, let's see this create option. So with the help of gcloud container Azure create, gcloud container Azure create, clusters create. With the help of this command, you will be able to create a GKE cluster in the Azure environment. If you see here, it's picking up couple of options like the location where you want to create the GKE cluster in Azure, and the region, the cluster version, fleet, which it is going to be part of that name, and then the address of your pod cider, and then the resource group where in Azure where it is going to sit. Like this, couple of detailed options which are provided here, as well as you will see an example for this. That's about the command line utilities. Now, if you see this API, I know the GKE multi-cloud API. If you see, these are the endpoints for different regions. Suppose let's assume you're creating the GKE cluster on East 2, Asia East 2. Then you will be referred to this particular API. If you come down, so these are the the API objects. So if you see get Azure server config, or if you see the example for create, so this is the post call using which you will be able to create the cluster. Like that, you can come down and you can see all the details for multi-cloud APIs. So let's come back to the diagram. So that's about this. So now to see the detailed architecture diagram, so here is the thing. So what happens is in your Azure environment, you will be creating a separate VNet, and then your Kubernetes control plane and worker nodes both are running inside your Azure cloud. So the control plane is consisting of three machines. I mean basically three masters. All your Kubernetes control plane components, like your etcd, API server, controller, all these components will be part of your Azure, environment itself. And these, I mean, by default, always, Azure creates three control plane machines, and these three control plane machines are balanced through Azure Load Balancer. So basically, the Kubernetes API server will be, exposed through this load balancer. So that's about it, the control plane architecture. And all your worker nodes are created again within this VNet as a part of different node pools. If you want, you can create node pools based on particular machine type. Let's assume standard D2S V3 is one machine family. So you can create pool 1 D2 D4S V3 or D4S V4, whatever the machine type that using which you can create another node pool, etc. I mean, it's basically depends on the individual business use case. And you can create different Active Directory groups. I know, like for example, if you create Kubernetes admin group, Kubernetes read-only group, and all that can be attached, to the cluster, and you can add the users to this particular group and maintain it. So here the key component for this entire stack is your Connect API. So whenever through command line utility, the kubectl utility, when you interact, this Connect API is the one which is responsible for connecting your fleet, basically. I mean the stuff which is maintained at the Google console to your Azure stack. So whenever you want, suppose let's assume you are given kubectl get nodes. So with the help of Connect API, it will go and interact with a control plane which is sitting in the Azure stack, and then it displays the output. So the same explanation, if you come down, it is given in this paragraphs and all. So that's about the GKE on Azure. Now let's go to GKE on AWS. So let me go back here. There you go. This is the architecture diagram. So here as well, it's the same method with a combination of multi-cloud API and Connect API. So only difference is here, rather than Azure, your control plane sitting in a typical AWS architecture where you will have a VPC and three different availability zones where you are creating your private subnet and public subnets. Here as well, your control plane is consisting of three master machines which are spread across three different subnets, and they are again maintained through your network load balancer. And you can create your node pools as well, in three different availability zones. I mean basically the subnets. And these, any of these worker nodes, since these are all private worker nodes, if they want to connect to internet and all with the help of NAT gateway, you can achieve it. So it's a typical, basic VPC architecture. So here, all the control plane components, which is like Kubernetes API server, scheduler, etcd server, and then your control manager. All those are part of every virtual machines, which are again, as I said, it's part of your maintained through your network load balancer. And you can have the node pools, even these node pools as well, like in Azure case, how I explained. This can be a combination of different Amazon virtual machine types. So that's the thing. And if you want to have any of the persistent volume and all, that you can achieve through Amazon EBS volume in case of AWS scenario. And in Azure scenario, I forgot to mention this, you will be able to achieve with the help of Azure disks. That's the only difference. But rest of the architecture is same. Where here as well, in the attached cluster, in the create cluster tab, if you come down, and choose AWS here and clusters, create. Same thing. You will be finding, gcloud container AWS clusters create command with yeah, there you go. With different options like I mean almost same options except that there are the options specific to that public cloud will be available here, like the AWS region, the cluster version, and again this is the key component. If you mention your fleet project, that is where it is going and creating, I mean, adding as a part of your fleet. That's the architecture at the very high level. So in the subsequent, sessions, I mean, in fact, I'm going to create a separate session for the implementation of GKE on the GCP itself, and then the GKE on Azure, and then GKE on Amazon. So thank you so much for watching this video, and please do subscribe to my channel and support me. Thank you so much, folks.